Okay, geometry students, this is the video for solving 45, 45, 90 triangles for missing side lengths without having to set up trig ratios. I'm going to try to make this less than 10 minutes, but that's going to be tough to do. If we had been in school for this section, we would have done an investigation where you would have measured the sides of different 45, 45, 90 triangles and answered questions that would have led you to the ratio that we're going to be using for our proportions. But since we aren't together to do that, I'm going to solve some right triangle side measures here using the Pythagorean theorem to hopefully help you see where these proportions are coming from. So one thing that you want to remember, no matter what problems you're doing with a 45, 45, 90 triangle, if you know one of the legs of the 45, 45, 90, you therefore will know the other leg. Because in a 45, 45, 90 triangle, if two angle measures are the same, two side measures are going to be the same as well. So in your practice problems that you're going to have to do, in a lot of the problems, half the work will already be done for you if they provide you with one of the legs. Please know that the legs are the sides that create the right angle. The side across from that right angle is, like we already know, the hypotenuse. So in this triangle, I know that one of the legs of the 45, 45, 90 is 3. That means the other leg is going to be 3. So I can fill that in right here with 3 squared. Now I could use the Pythagorean theorem, honestly, on all 45, 45, 90s to get the answer to the missing hypotenuse when I'm given one of the legs. And you could also use the Pythagorean theorem to find a missing side leg when you're given the hypotenuse. But this lesson is about using the proportion that we're going to see come through hopefully in all 3 of these examples. So 3 squared plus 3 squared is 9 plus 9, and 9 plus 9 will be 18. So now I know that y squared is equal to 18, but I can't leave my answer like that. So I need to take the square root of both sides, and I'll find out that y is equal to, let's see, the square root of 18 breaks down to 3 times 3 times 2. So 18 is 3 times 3 times 2. Because there's a pair of 3's, I can move that out in front, giving me 3 times the square root of 2 for my hypotenuse. So this side is 3, this side is 3 times the square root of 2. Okay, now I'm coming over here to a triangle whose leg is 10. And I want to find out what the other leg is and what the hypotenuse is. Whoops, I forgot to put my angle measures in here. So these are all 45, 45, 90s, by the way. So if one leg is 10, we know the other leg has to be 10, and I can put a 10 right in here. 10 squared plus 10 squared is 100 plus 100. 100 plus 100 is 200. I'm going to take the square root of 200. Let's see, 200's factors are going to be 2 times 2 times 2 times, let's see, 2 times 5 times 5 should be 200. 8 times 25 is 200. So I have a pair of 2's and I have a pair of 5's. So 2 times 5 can come out and the square root of 2 is going to stay in. So I'll find out that the y is equal to 10 times the square root of 2. In the last problem, y, the hypotenuse, was equal to 3 times the square root of 2. All right, let's do it for this triangle here. One leg is 1. That means the other leg is going to be 1. 1 squared plus 1 squared is 1 plus 1. 1 plus 1 is 2. But that's what y squared is. That's not what y is. So I need to take the square root of both sides, and I find out that y is equal to the square root of 2. So now, I ran out of room over here, so I'm going to have to erase some of this stuff. Now I want you to see where our proportion is going to come from. So what I'm going to do is I'm going to set up ratios that compare leg to hypotenuse in all of these. Leg to hypotenuse. And this leg ended up being 10, and this leg ended up being 1. So leg to hypotenuse. Over here, leg to hypotenuse. And over here, leg to hypotenuse. Now what we want, I made a mistake here, sorry, it wasn't square root of 2, it was 10 times the square root of 2. What we would want is one ratio that works for all of these. Now, I don't know if you see this one is in lowest terms. The side legs, the leg lengths are 1 and 1. I can't get any smaller than that. Let's go to this one. Is there a way that I can decrease all of these measures by the same multiple? Looks like 10. If I divide all of these by 10, 10 over 10 is 1. 10 over 10 is 1. 10 times the square root of 2 divided by 10 is going to be 1 times the square root of 2, or just the square root of 2 like the ratio is over here. Okay? All of these seem to have a common multiple. They all have a 3. So if I divide them all by 3, 3 divided by 3, 1. 3 divided by 3, 1. 3 times the square root of 2 divided by 3 becomes the square root of 2. So through your activity that you would have done if we would have been in school, you would have figured out that the side legs are in the ratio of 1 to 1, and the hypotenuse compared to the legs are in the ratio of 1 to the square root of 2. So now that we have this proportion or this ratio, we're going to use that ratio to help us build proportions to find missing lengths in any 45, 45, 90 triangle without having to necessarily go through the Pythagorean theorem. Okay, although the Pythagorean theorem will work. So in this triangle, let me situate your screen here a little bit. So our goal is to be able to find missing measures in a 45, 45, 90 triangle by using the ratio leg to hypotenuse, which is 1 to 1 to the square root of 2. Or from that, we can write a proportion where we compared leg to hypotenuse, and we compare it to 1 over the square root of 2. So that's what I'm going to do. I'm going to use this already pre-made proportion to find the missing measures over here. Now, in this example, we're already given one of the legs. Across from the 45 degree is one of the legs. So across from the other 45 degrees should be the other leg. Half the work is done. Now, if I want to find this, which is the hypotenuse, I want to write a ratio that compares a leg to a hypotenuse, 9 is to y, as 1 is to the square root of 2, because that's the ratio for every leg to hypotenuse in a 45, 45, 90. So now if I cross multiply, y equals 9 times the square root of 2, so my hypotenuse is 9 times the square root of 2. Remember, this only works for 45, 45, 90s. Okay, now over here a little bit different. This one I'm given the hypotenuse to start with, and I have to find the legs. But the nice thing is, once I find one of the legs, I'll know both of the legs. Okay, we're at 9:45 right now. I'm not going to get in under 10, but I'm going to be close. So I'm going to write a ratio, leg to hypotenuse. Leg is y, or x, whichever one. hypotenuse is 2 times the square root of 6. And over here, my leg in my triangles from my other whiteboard simplified to 1. My hypotenuse always simplified to square root of 2. This is going to be a little bit more complicated math to solve, and of course there's a glare right there at 2 times the square root of 6. I'll move it in a bit. So when I cross multiply, I'm going to have y times the square root of 2 equals 2 times the square root of 6. And right here now is why you were doing some of the work that you were doing the last couple of days with radicals, because I got to get y alone. So I'm going to have to divide by the square root of 2. But don't panic. I have a square root of 6 being divided by a square root of 2. They're both inside of radical signs, so I can divide. 6 divided by 2 is 3, but it has to stay inside the radical. So 2 times the square root of 3 is what the length of each of the legs is going to be. So make sure that you're using this proportion right here. Always put your leg measurement on top, your hypotenuse in the denominator with 1 over the square root of 2.